As the prototypes have been maturing, it's now time for commercial applications to begin. This means the manufacturing of large-scale wave energy devices. Ocean Power Technology in New Jersey has seen the great potential in Oregon and contracted with Oregon Iron Works to produce their first buoy.
So tell us about the BP150XI manual transmission.
The PB150 is 150 feet long. The biggest part is 40 feet in diameter, and it weighs about 220 tons. So it's a big piece of equipment. But when it's in the water, there's only about 20 feet of it that stick above the surface. The OPT buoy alone created or sustained 35 jobs. We issued about $800,000 in purchase orders to companies around the region.
What did that buoy cost?
Between $3 and $4 million to build the buoy. Remember, that's the first one. We'll put one buoy in, we'll see what the changes are. We'll do some adaptive management as necessary, and then we'll put more buoys in. So the deployment of buoys is going to be a phased deployment. Oh, yeah. You put one in, you put 9 more, you may put in 15 more, and every time you're going to look at it and say, okay, what's going on here? Because we want to make sure that we deploy devices in a responsible manner.
Just to give you guys an idea of height here, we're standing on this platform at around about 60 feet. The bottom part of this contraption is about 40 feet tall. So actually, by the time it's all put together, it's going to be about 120, 30 feet, about 3 times the height of where we are now. Well, can we get down and see the main structure?
Yeah, I want to stand by that shaft. Show folks how big that thing is.
Let's go look at the spar.
And the buoy.
What is this thing?
So this is the float, and this is what goes up and down and creates the energy in a lot of ways. You can see it's got a bolt line here, so it comes in 2 pieces, and then it'll go around the spar, and the guides on the spar will are what this will run up and down on. When this goes up and down, the bridge goes up and down, and there is an input shaft that goes from the bridge down inside the spar, and that's what will drive the electricity production inside the spar. This is a spar section. It has all the electronics in it, all the conversion to convert the linear motion into electrical power. It's 103 feet long, and it weighs over 80 tons.
So when the whole thing's put together, what's the entire weight?
It's going to be about 280 tons.
These are the slides where what we've just seen, this is where it moves up and down. Right?
The float will travel, and it's got slide plates that will ride on this stainless steel surface. It's machined flat.
So when you take it out in the ocean, will it all be in one piece, or you assemble it actually out there on site?
It will be assembled in a yard and then loaded on a barge as one piece, and then transport out to the deployment site, and then put in the water. And again, like I say, it's going to be horizontal. They flood the heave plate, and this whole thing's going to swing down, and so your heave plate's about 90 feet underwater.
And what is yellow is the part of this thing that stays out of the water. So if you have a look along the back end here, you'll see that there is a huge amount of this thing that is submerged.